Also we have V1. Here there is no loop, therefore the element will be 0. Here V1 and V2 are adjacent because there is a edge between V1 and V2, therefore the element will be 1. Here V1 and V3 are also adjacent, therefore here we are going to put 1. Next we have to fill the second row. Here this is an undirected graph, so V2 to V1 also we have an edge, therefore here we are going to put 1. And V2 to V2 don't have an edge, there is no loop, therefore the element is 0. And V2 and V3 have the edge, therefore the element is 1. Now we have to check with V3. V3 vertex is adjacent to V1, therefore we are having 1. And V3 vertex is adjacent to V2, therefore we are going to put the element as 1, whereas V3 does not have a loop, therefore the element will be 0. Okay, hence we have found the adjacency matrix for this graph. The most important properties for this adjacency matrix means an adjacency matrix completely defines a simple graph. We will find the adjacency matrix only for a simple graph, and the adjacency matrix is symmetric. Symmetric means what? A equal to A transpose. If we are going to find A transpose for this adjacency matrix, we are going to get the same matrix. So we can call it as symmetric matrix. Okay, these are the basic important properties for this adjacency matrix. Okay. Now the adjacency matrix for one more graph. Now if you look at the screen, we have the graph. It has 6 vertices. Now we have to find the adjacency matrix for this graph. So it is denoted by AG. Here we have 6 vertices, so we have to write the vertices in the side and on the top. So it will be easy to fill the matrix. V3, V4, V5 and V6. Now we can start filling the matrices. Here V1 is not incident with V1 again, that is not adjacent, so the element will be 0 here. V1 and V2 are adjacent, so 1. V1 and V3 are adjacent, so here the element is 1. Whereas V1 and V4 are not adjacent because there is no edge between the vertex V1 and V4. So here we have to put 0. And there is no edge between V1 and V5, therefore it is not adjacent, therefore we have to put here 0. And there is no edge between V1 and V6, therefore we have to put 0 here. Now we have to fill the second row of the matrix. Here there is a edge between V2 to V1, so here we have to put 1. There is no loop in the graph for V2, so here 0. And we have to look for V2 and V3. There is no connection or edge between V2 and V3, therefore here we have to write the element 0. Next, we have to check for V2 and V4. There is no edge, therefore here 0. And next V2 and V5. Yes, there is a edge, therefore we have to put here 1. And we have to check for V2 and V6 vertex. There is no edge, therefore here we have to put 0. And we have to fill the third row of a matrix V3. Similarly, we have to do the process V3 and V1. Yes, there is a edge 1. V3 and V2 don't have an edge, therefore 0. V3 and V3, that means there is no loop, therefore 0. V3 to V4 have the edge, therefore 1. V3 to V5 we have an edge, therefore 1. And V3 to V6 there is no edge, therefore 0. And V4 to V1 there is no edge, therefore 0. V4 to V2, there is no edge, 0. V4 to V3, yes, there is a edge 1. And V4 to V4 to V4, there is no loop, therefore 0. V4 to V5, that we have an edge, therefore 1. V4 to V6, there is no edge, 0. And V5 to V1, there is no edge, 0. And V5 to V2, we have an edge, therefore we have to put 1. V5 to V3, we have an edge, therefore we have to put 1 here. V5 to V4, we have an edge, therefore 1. V5 to V5, no loop, 0. V5 to V6, yes, there is an edge. Now V6 to V1, no edge, therefore 0. V6 to V2, no edge, 0. V6 to V3, no. And V6 to V4, no, 0. V6 to V5, there is an edge, therefore 1. And V6 to V6, there is no loop, therefore 0. Now, how to check whether the found matrix is correct or not? You can check for the symmetric matrix condition. If the matrix is symmetric, your results should be same. The what you have found will be similar to A transpose. If it is correct, then your adjacency matrix is correct. Okay. Thank you.